And we're live yet again. And Josh, you finished. Oh, he has
Hello.
appeared. He has appeared.
Yeah. Object permanence. I was there before we did the intro, and then
Yeah.
it was gone. It's
I
like, where's
wasn't paying
Josh?
attention. I didn't know if that was planned or not. Like, oh, I need to grab something. I was like, oh, okay. Well, here I am. At least here I am.
Yeah.
But you're
I
here.
figured I'd swoop in.
Well, it's a good effect. Good effect.
Thank
We should
you.
do
Thank
some
you.
like fade to black, fade in, fade out.
Yeah.
How are you today? Is it? We're not back to back. This is the first time we've done it without several days in between.
That's
Feels
right.
like it's going to be a little bit smoother of a pickup, I think.
Don't jinx it.
I've got a wooden desk I can knock on.
Oh yeah, I think I've got a bamboo, but it's like coated in a layer of plastic or veneer or something.
Okay.
So if
I've
I
made
knock
it as
on
well.
it, do I knock wood?
I don't know. Bamboo's technically wood. It's
Yeah,
eventually wood. I don't know.
That's fair. That's fair. What is the universe if not a big tree?
In some way, a graphic.
Yeah.
All right. So today I think we're going to be diving back into the playground, but we're going to work on finally getting it to be a WebAssembly component. I think
we're gonna try.
We're gonna try.
Yes, but it would be great if we could like get that working, because that is definitely what we're like going for.
Yes. Let's see here. So I guess we can dive in. Well, did you have some new equipment you wanted to show?
Oh yeah, I do. I feel
like this is a pattern now that we just have to continually compile.
That's right. So CatCam. I now have a little black square made by a computer company in California, I believe, and they make these really neat little squares. And you can click on them. It's got a little motor in it, so it's like really fun. And then it's still my usual keyboard, 60%. But I want to switch this one out for the like dual, and then I have like two things here, and then my little black square in the center, and I can like tap, and then I think it'll be like lovely. But yeah, this came in the mail today. I ordered it a couple days ago, and so far I can't say I like it, because the movement going from here to here is like a really big motion rather than just grabbing the mouse. But I'm hoping with a new keyboard this will be like a little smoother.
I think it will. That seems to be the end game layout for a lot of people. They go split, and then they have either a trackball mouse or they have that trackpad in the middle, and that seems to be. Otherwise, you're kind of doing a shoulder shrug,
Yeah,
back and forth. Which maybe, I mean, if you want to work on your traps, it might be good to keep.
Yeah. Micro workout.
Yeah.
Okay.
I mean, imagine how many reps you get in a day doing that. Like that's gonna be thousands. Good for you.
Yeah. Me hunching over is actually exercise to like get better at my what's that exercise there?
Shoulder shrug, right?
Shoulder shrug. Yeah.
I just got back from the gym, so my pre-workout. So if I'm a little above what I normally am, that's probably why.
as in mass, like you're pumped out.
No, just like from the pre-workout that I take.
But, okay.
I don't know. Maybe my shoulders look bigger. I don't know.
Oh, okay. Yeah. Yeah, dude. I also just came from the gym. Turning the stream into like, hey, we're doing computers, everyone, to just like flex.
Well, we both work on the back end, and that's kind of like the stereotypical. Have you seen those memes where like the front end guys kind of like a little bit thinner and skinnier, and then the back end developers just always jacked?
I thought for a second you were going to say like, and that's why we do squats and the front end people do push-ups. The front end, the back. Yeah.
Okay. Yeah. Front, top. I see where you're going.
But no, okay.
All right. Well, I guess let's dive in. I thought, so you shared a blog post with me yesterday on stream, and I thought it would be good just to dive in.
Oh yeah. Yeah, we can do that.
So let me know if that's legible. I can increase it if we want.
Hold on, I'm gonna like right now for me, no, it's absolutely not legible. But also, I'm looking at a screen the size of a postcard.
That's true. That's true. Well, it should be okay. I mean, let's do.
I think if you up it one more, yeah, that's great.
Right there. All right.
Yep.
Fantastic. Very good. So you wrote this. When did you write this? Last year? Last June?
Last year. Yeah. One of the things I like for blog posts is like when they put the date like big. And so I decided for my like blog, I'd put the date like
in the
The
title almost.
biggest?
The biggest.
Yeah.
Because yeah, it's a relevance factor. So this is what is WASI. And so we were
Yes.
building a component, and I'm still building out all the mental models for
Mhm.
this technology. So these are actually really good articles for me to read. So
I wonder how well it's like held up, because this was about half a year before we like released the thing.
mhm.
Now I wrote this as I was like learning about it, because I got like very confused. So I was like, oh, what's the difference between
Hmm.
WebAssembly and components? And people kept
Oh,
saying the word
writing to
component
learn.
model, and I was like, what's that?
Goodreads. That you what you just said reminded me of this book that I mostly read. It's called Writing to Learn.
Oh, nice.
Yeah. So for anybody that's readers that's watching the stream, this is a good read. If you're kind of stuck on writing and you've got kind of, I don't know, imposter syndrome or just like writer's block or whatever,
Uh,
this is what I've always fallen back to. And whenever I've veered from this methodology, writing gets hard. So if you really just write to learn and keep that in
mhm.
mind, it keeps you humble enough. But then also, because one thing that I've gotten into when I write is, like, oh, I'm not the subject matter expert here. Like, there's a lot of people out there that are more knowledgeable than me. But a mentor of mine a while ago named Don Jones said, there's always someone right behind you that what you write is going to be
Oh
way
yeah.
more applicable to them. So yeah, this is a good book to kind of get you through that and gives you a lot of practical advice on like how to use writing as a tool for learning.
Mm.
So yeah, so it looks like you did that right here. So if we look at maybe should we just jump down to what is a WebAssembly component and
Yeah,
then okay.
sure.
All right. So WebAssembly, I'm going to read it and then we'll see if it holds up and then I'll
Okay.
ask questions from there. Because I think this is good context because a lot of people like we're going to build a WebAssembly component, but my first
Yes.
question is even after like tinkering around with it for a little bit is like, what is it? What really is it? And what is it
Mm.
supposed to do for us? And hopefully this enlightens us. We'll find out.
I hope so.
Or at least me. You wrote it, so maybe it'll refresh your mind. But anyway, WebAssembly as a bytecode format
It is.
is a bytecode format is also often referred to as core WebAssembly. When you compile a core component, and I'm not going to judge grammatic errors because I
Yeah,
definitely
yeah, yeah.
make
I'm
them on my
immediately
own.
like, oh my god, I should like proofread this like better.
So I did a newsletter for a little bit,
Mhm.
and I published the first couple, and then my wife was like, "You need to." I'm proofreading your articles now, like because it's terrible. Like the
Yeah,
message
yeah,
is good, but the grammar makes it hard to read. So she was my
yeah.
editor for a while and did a great job. Anyway, newsletter does not exist for
I
anyone
wish
wondering.
sorry, on that topic, like
Yeah,
I by the way, I love our little like, side quests, conversational side. What do you call it? Like
I guess side quests would be
segues?
segues. Yeah.
But like I would love a plugin for VS Code that
Mhm.
gives as good of like hints and editor stuff as like Word or similar tools have. Because like,
They do exist. There's a license. I did have it for docs. What was it? Acrolinks.
oh,
Yeah, so that might be something that you could look into. You might be able to get a license through our employer, but I don't know. But that's what I
okay.
use for docs, and because they essentially had lint tests for the docs. Like
Oh,
you had to hit 80% marker in this, da 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 da, and it
interesting.
would catch like that phrasing. Acrolinks is the name. I think I did a podcast episode with some executive there once a while ago.
Uh-oh.
I don't know, it was a while ago. Previous life. So when
Nice
you
man.
compile, let's see here, when you compile a core WebAssembly program, it is converted into something called a WebAssembly module. Okay, that I remember
Mm-hmm.
that. I remember doing that and trying to use a module as a component. You're like, no, 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 don't do that.
Yeah, yeah, yeah.
You can roughly think of it as an object file in a traditional compilation model, but unlike classic objects, WASM modules can't describe system calls or reference any external symbols. So external symbols mean like anything else on the operating system.
Yeah, like a symbol, like a what we mean by symbol is you have, for example, a function call, right? In your source code, you say function meow or something,
Okay.
and then you compile it, and in the binary, that name is oftentimes like prefixed, mangled, turned into a thing, but it becomes like a global referenceable thing, and that thing is a symbol. So it's kind of like
Okay.
a function name.
Okay. Okay.
Yeah.
Okay. They can only take numbers in and put numbers out.
Yep.
And that's about it. If you're
Yep.
trying to make a WASM program do anything other than sum up numbers, you need more than just core WebAssembly.
Yep.
WebAssembly components. Okay. So because it's binary or because it's in binary format, like why can't core WebAssembly do more than numbers?
So if you think about your CPU, right? Like
Yeah.
the instructions that your CPU can execute, like your CPU doesn't know what a string is. Also,
Right.
your CPU knows like, oh, here's numbers. I'm gonna sum numbers, change numbers. I know what a pointer is. I can jump to places, execute more number stuff. And then things like strings, we encode our higher level understanding of like, here's a sequence of like words or characters or whatever into like a low level format that is essentially just number operations. And so WebAssembly, just like your CPU, just like assembly, can only like really reason about numbers. Right? It says like, yeah, I can take some numbers in, I can do some stuff on those numbers, and here's more numbers back. And so that like the core instruction thing only works on that. And so we have to wrap it to like
That
teach
makes
it.
sense because the CPU itself, it needs some kind of way to reason about a string, right?
Mm-hmm.
Because through coding, and there's a lot of ways to do that.
Yeah.
Okay, that makes sense.
And things like Unicode or ASCII are like the conversions from our like character representation back to number representations.
Mm-hmm.
Then we have sequences of numbers and memory stuff and like read numbers until yada yada yada.
Go help me understand that.
Yeah.
Because everything, like when you give it a string and you try to loop through it, it'll give you runes, which is like a digital, like a byte representation, but then those runes match to numbers, I think, that are
Runes?
Unicode. They're called runes.
Is that a Unicode term?
I believe so, because then that Unicode gives you like a number value for it. Hopefully I'm remembering that properly. But then like if you know what A is, like A is 62 or something like that, then you can, compare. Like I figured that out with comparing strings, some LeetCode stuff.
I think what you might be referring to as runes might be code points in
Code points.
Unicode.
Okay.
I'm not super sure. There's a full string, and then there's individual like characters, and then there's the individual components that make up characters. I think code points is like the higher level characters, and then there's like one more beneath that.
Rune is an alias for an int 32, a representation of Unicode code point. Bingo.
Oh, there we go.
Nailed it.
Yeah. Oh, that might just be like a Go term. So in Rust, what we call rune, or what you call rune in Go, might just be like char, like char in Rust.
Okay.
Potentially.
Okay. Yeah. Where else was char used? What other language?
C++.
Okay.
Yeah.
All right. Side quest complete.
Okay. Yeah, we keep like dipping in, but I enjoy it.
It's good context.
Mm-hmm.
So WebAssembly components, and I remember this being mentioned in the release, are typed wrappers around WASM modules. So rather than reasoning about numbers in numbers and out, they provide a way to talk about types, functions, methods, and namespaces.
Mm-hmm.
The way this is done is via the IDL format called WIT, WebAssembly Interface Types. Here is
an IDL format. There's many different IDLs.
Okay.
And this is
what
one of them.
is an IDL? Interface Description Language.
Yes.
Okay. It's a generic term for language that represents a program or object written in one language communicate with another program written in an unknown language.
Mm-hmm.
Usually used to describe data types and interfaces in a language independent way. Okay. So that's how I can talk between languages with that WIT interface.
Yeah. For example, protobuf v3 and above is an IDL.
Oh,
and
okay.
then or
yeah.
What's the protocol thing called on top of protobuf? The Google thing, gRPC.
gRPC. Yep.
Yeah. So gRPC is described in terms of protobuf. And what you do with protobuf, it allows you to code gen language to language bindings that run over the network. So it's not direct linking, but it's networked operations.
Mm-hmm.
And Google has a code base that says, okay, given this schema, I will generate you a Java client and a Golang server or something. And then the intermediate description, that abstract layer, the protobuf, is an interface description language. It says like here's the interface, and then you can generate servers and clients like from both.
Interesting. Okay, so that's gRPC and protobuf are things that have been on my like to research list for a long time. So this gives me a nice hook into understanding, because then it'll give me more mental models for WebAssembly. Sweet. Okay.
For example, OpenAPI or Swagger is arguably also an IDL.
Okay.
The C programming language arguably is also an IDL. At this point, we treat it more like a compat layer, where we say like, hey, these structs have this layout, and using this layout and like this function interface or whatever, we can make calls to the operating system. So we don't, like, for example, Rust, you don't write C code directly, but we have a C compat mode that makes sure that our structs and whatnot are like in C layout. And that layout essentially is an IDL. You can take C header files and generate like Rust code from it, or like bindings to it, So yeah.
Interesting. I wonder if that's more or less what I created many years ago when I was changing. Yeah, maybe. That's a side quest we don't need to take right now. Okay. So the way this is done is via an IDL called WIT. Okay, here's an example. So here we have an interface, monotonic clock.
Monotonic.
Monotonic clock. Okay, so use pull.pull. Type instant equal U64.
So the use statement is like an import.
Okay.
Where we say, hey, we're from the namespace poll, the world poll, we're gonna take the pollable interface. And that's an import.
We talked about that on the last stream, where I should get a bigger. Don't think I can increase the text here, but like there's WASI, and then there was like, in this case, would it be monotonic clock?
Can you up your font size for the notepad slightly?
Let me just use code, because I can do that in
code. Okay. Sure.
Oh, I don't want that. I want a new file. There we go. So minimize this. Now we'll move it over here. Make it a little smaller. There we go. And now I have Vim, so that's even better. Okay, so WASI is that reserved namespace, and then so would monotonic clock be next, or would there be something else in between?
So the way you'd write this is like WASI : using the inside of WIT, the names. So WASI : WASI is the namespace for all of the standard interfaces. Then clock would be the we looked up the name for that yesterday. I forgot again.
Well, you had a taxonomy down here, didn't you? This is where you got it from.
Did I?
Yeah.
I hope so.
As a module component.
No, I think it might have been like slightly above.
Namespace.
Yeah. Oh, is that the only? Oh my gosh.
World?
No, it's not world. It's the other one.
Oh, what was that word that you used to describe it?
Exactly. It's like namespace is the top level one. World is what comes after.
Well, here is the appendix. I think that you got it from.
Did I?
Yeah, yesterday when we were talking about it, there's worlds, preview, linker, module, IDL, WIT. Maybe it was a different blog post. I thought it was this one. Fairly certain it was this one.
I know I pulled up the spec as well, which I'll do again now. The WIT format. Namespace. Oh, package.
Oh, okay.
Yep.
So it goes namespace package
Yep.
world, right?
Slash world. So
Slash
not
world,
colon, but slash. Indeed.
like that. Okay, so it would be
And
WASI.
you can add more to it, by the way.
Okay, more.
At, and then a version. Oh, so no slash, just at.
Oh, okay, at version. Got it. Okay.
And the version must be Semper.
Semper. Okay.
Yeah.
Is that font size okay? I can go higher.
Yeah. I can. Okay. Oh, even better.
Even better. All right. So our namespace would be WASI,
Uh-huh.
and then the package would be in this particular case.
Clocks.
Clocks. And where's clocks defined?
Not in this file, but
it would be a different
wrapping.
One. Okay. So now it would be, so that's the package. Namespace is WASI. It's in the package clocks, and then the world would be the monotonic clock.
I believe so. Or that's the interface. The world. So again, not shown here.
Okay.
Would probably be monotonic.
Okay.
I'm trying to guess now. We can pull up the WASI.
Oh, that's okay. That's okay. I mean, it's all an example. So
yeah.
Monotonic at like V1 or something. Okay.
Oh,
and then that would so then in my code, whatever I'm writing and using when I'm going to be using this clock, I would call the interface, or define it, or like how would I call into this?
Like, how would I use say it? Like you would say use
like
in your Rust code.
Yeah, or Go right? Code. Like we could use it, right? Like import like WASI clocks like that.
Okay. So
it doesn't have to be like Go specific, it could be, this is just pseudocode. Like how would I use this now?
Yeah. So the important thing here is you can't directly import WASI interfaces. You must first do code gen. But the code generator would likely follow the hierarchy that we've defined.
Okay.
So I don't know Go notation. So you're gonna have to check that line
6.
That this line actually is like valid Go code. I don't know.
Yeah, it would probably need to be like the GitHub repo or something like that of wherever the package was from. But from a pseudocode perspective, like we would import said thing. And then how would we call said thing?
You would just call the function name. So whatever function you want to call, you call that one.
So what would
for example, now is a good one to target.
Now, like that, something like that.
WASI clock so monotonic is still namespace. Like an interface, you can think of as a namespace, like a sub namespace.
.now, something like that.
So WASI .clock .monotonic clock or monotonic, and then .now.
Clock. Was it? Yeah.
I guess we called the namespace on line 7 or 3. We called it monotonic. It doesn't matter. Like
something like this. Okay. So that's all I was trying to get to, is a pseudocode of like how would I import and stuff. Okay, cool.
Exactly.
This is helpful. This right here. This we should add this somewhere because we keep coming back to it. Namespace package world version. Got it. All right. Continuing on. Let's see. I've been neglecting. No comments so far. That's fine.
Oh, okay.
Been neglecting it, but there's nothing there, so we don't have to worry. So, WASM component is a single typed object consisting of a core WASM module plus corresponding WIT definitions. Okay. Components can specify they either export specific interfaces or require that other interfaces are imported. For example, I could write a binary program which prints the number of seconds lapse, which exports a main function with no arguments and imports both standard out and the monotonic clock interface. Okay. One way to think about WASM components is, what if we had machine learning?
Meta
language style modules in our linker.
ML is like a heavily overloaded term. You immediately went to machine learning. For type system people, it's of course, it is meta language.
Got some love for your GitHub profile.
Thanks. But then if you talk to lefties, they'll be like Marxism, Leninism in our module system, and it's like, yeah, no, that's not. This is ML as in meta
Okay.
language.
Meta language. Okay.
Yep, which is Haskell and OCaml.
Okay.
The ML in OCaml is meta language. They're both like ML derivatives, which is a family of languages.
Okay.
You've heard of? Have you heard of OCaml and Haskell?
I haven't
Haskell,
yet.
of course.
I've heard of both. Never used them, or like
Okay.
not too familiar with the term meta language.
What it comes down to, again, little side quest.
Okay. Yeah. Side quest. Meta language.
It depends. So ML style languages, they're sort of their connective tissue, like across all of them, is that their type systems are what we call sound, as in their type systems. Basically, you can treat them as like a proof system, which means that if it type checks, then it like very useful properties come out of it. Like it's unambiguous, like it'll for sure like compile in a certain way. You can still have like runtime stuff that's like not encoded by type system, but it makes it very like type heavy, very like proof heavy, very like, gives you a lot of assurances.
Okay. So that's probably why it's often used with languages that aren't typed. What's that? Like, what are the use cases in there?
It's like, how do you say this? Like the more you can have the compiler check during compilation, the fewer bugs you'll have at runtime,
right.
essentially, and the fewer tests you need to write because the compiler's already like verified a bunch of stuff. And like ML style languages, they are very on the like, hey, we're going to check a bunch of stuff for you during compilation.
Okay.
Rust arguably is an ML style language. It just looks like more like a C like language, but the type system is like, Hindley Milner compatible. It doesn't matter, but it's like what your type system is. TypeScript, for example, you can't like it does not have an ML style like type system, which means that if it compiles, there may still be like, it may not be sound, there may still be like errors and stuff.
Right. Well, I think that, what does the term go? Uses statically. It's a static language with the types. Like every type needs to be defined. It won't let you compile without it.
Probably. I'm trying to like, how do I explain this without
Yeah,
like
it
going super
makes
deep into
sense
it?
from. Oh, it's more strictly. The types are strict. That was what makes sense in my mind.
It maybe a better way of phrasing it is like the types have a mathematical model, which is like deterministic. Like there's math backing the type system versus the math doesn't check out for a type system. It may still be useful, but it doesn't fully like, you can't like convert it to like, sit down and convert it to like a formula and then like type check it, because that doesn't.
Well, that's what you meant by
hold.
proof. Okay.
Yeah, like a mathematical sort of proof.
Okay. Makes enough sense.
And so the cool thing about this is what I was trying to say here is like, and again, I was assuming like, of course, everyone knows what an ML style like module is. Nobody knows what this is. Clearly, it's just me with my type brain. But what I'm trying to say is like the type system for wit and for components, it is like, it's mathematically like sound. And so when we create our bindings to it, like any language which it also has a type system like that, we'll be very happy with that, because it's sort of like, hey, if this is like sound and I can create like I am sound, then it transfers perfectly. And even for things like TypeScript, like, you start there and you convert to TypeScript, then hey, that's actually still like very nice.
Okay. So it cares about types.
Yes. Great summary.
Okay, and that I thought was taken all the way through to the system call layer to be the way binaries are linked to each other, with the added benefit that each WASM component operates as its own security boundary, using a shared nothing approach to ensure isolation.
Yes.
Okay.
That's a really cool property about WASM that in our conversations we've like not been emphasizing, but each component, you can think of it as running inside of its own sandbox, or not even think about it. It runs inside of its own sandbox, which means that if you say you have a malicious component, right? Someone's like, ooh, dependency inject, or like, vulnerability injection or whatever. Someone manages to find an exploit. They won't affect the rest of the system. They can't like mess around with pointers and jump into like another component because it just is impossible.
Does that hold up for component composition? Like when you combine them, they're still each component.
Mhm.
So can we let's dive into a little bit more what's that sandbox means? Does that mean it has its own memory block
Mhm.
and like it can't talk to other memory blocks and other memory blocks can't talk to it?
They can talk to each other, but they can't share memory with each other in
Okay.
like unbounded ways.
So unless you've exposed how it can talk, like through an
Mhm.
export, then it
Mhm.
can't. Anything inside of it cannot be accessed. That memory block.
Correct.
Okay.
Yeah. Yeah.
Unless you're explicitly stating what can be exported or sent
Mhm.
out. Okay.
Yeah. And even then there's like real limitations about like, so you can't have like writing to one side here but also reading it, like writing to the same thing and have races. It really is like, I have opened a file, I am going to hand you this file, and now I no longer have this file. So one component says, here you go, and it loses the access to it, and the other gains the access to it. So you can
Okay.
share things with each other, but it's like very segmented. And this rules. This is like like, I don't want to bore you with like capability based security and like all that stuff, but like,
I'm somewhat familiar with that from
yeah,
the container world because they're trying to get away from being in control of everything and go to basically leverage Linux capabilities, but like what's in the kernel.
yeah,
Okay. Well, this seems like a
in
faster track to that.
yeah. And so when we talk about things like Hyperlight, what we're saying is like, okay, let's grab this already capability based like system with like shared nothing, everything's already isolated, and let's put all of that inside of a real VM. So like an actual like linear memory slice that's like segmented from everything else. And that yeah, it's a lot. It's
Oh,
like we're like a so many layers of like security and isolation at that point. It's the best.
good deep dive for another one. This is what I read to get an vague idea of Hyperlight. Let me
Oh
put
yeah,
this in the chat for everybody that's interested.
that's Aaron's blog.
Yeah. Yep. Aaron's blog. He worked. Yeah, he works with David Justice, doesn't he?
No,
No.
he moved. He
Oh. Okay.
left a couple months ago.
The company.
Mm-hmm.
Oh. Well, that's sad.
Yeah, it is.
Okay. Let's see here. Okay, so we got a general understanding now. Okay, so a component needs the WIT file because that's the IDL that communicates between languages.
Uh-huh.
And it provides types and functions. Where's the types? Types. Yeah. Typed wrapper around the WASM modules. So that way you can use them between. So this means that you can use them between languages, but also other modules or other components. Right?
Yeah.
Okay.
Yeah.
So the way go ahead.
So before WASM, like you don't need WebAssembly components to create wrappers around like core WASM. In the past in Rustland, like 2019, we have I guess still this project called WASM Bindgen, and it says like, hey, I can create bindings to the web, and it does so in like a custom way. And it'll custom create the bindings, and there you go. But the problem with that is if everyone has their own custom way of creating bindings, then nothing works with each other. Like one of the problems we ran into with WASM Bindgen was, hey, it's a custom thing. There's no target. There's no standard. How do we like pull this project into the compiler? Or how do we like get everyone to agree with this? Or how do we take the same approach and make it work for Go or .NET or Python? And the answer was, we can't. And that's why the component model was created, which says like, okay, we're going to create this typed wrapper and everyone agrees on this wrapper, and now everything can talk to everything else. That is actually working out really well.
Okay. So without the component, we wouldn't be able, with BindGen you would be able to, but that's kind of like is a limitation with BindGen, like say I have a Rust code base and I run it, it'll work to translate Rust to WebAssembly, but then it's going to be different if I do a different language.
The problem, like the problem is not so much that you can't do it once. Like, we can do it once, and we can even share that for other languages.
Okay.
But it's like, as long as you don't standardize it, as long as you don't all agree for every language out there and for everyone to get on the same track, you'll always have like a really awkward experience where it's like, oh, the Python tooling does a different thing. It generates different types of bindings than Rust does, than Go does. And so everyone's sort of like disjoined and a bit chaotic, which is why you want to standardize those things, like actually put them on the standards track. And that is WebAssembly components.
Gotcha. Okay.
Well, like, there are like alternatives out there, and there's like companies who are like, hey, you should use our bindings generator instead. And it's like, okay, whatever the quality is, like that's not a standard, or it's not being standardized. And so,
Okay. That makes more sense to the reason behind it. The motivation behind it, I suppose. That's a better way to put it.
By the way, sorry if I'm like chatting too much. I feel like
no, this is all like super good. But I learned I always learn like a ton about programming every time we chat, which is great for me. Okay, so I guess now that took a little bit longer than I thought. 37 minutes in, but that's good.
Which is why I'm apologizing, because I'm like, I am doing story time with Yash. Every paragraph has a tangent.
I forgot to. So hopefully we'll be able to switch to OBS, and I've got like a bunch of things that I want to do. So every time we go into story time, what I want to do is bring up a Diablo, Decker, Kane, stay a while and listen. Yeah, I want to pull up one of these images. Yeah, we'll do this one. Stay a while and listen. And then it'll be like story time at the bottom or something.
Yes.
I think that'd be cool.
Yes.
All right. So I've got a better understanding. I think now what will cement it is attempting to build it or going through it. So, because we'll get all those different things. So let's bring up VS Code. So I think I need to bring in a playground repo. So if I look at here, I think I've got the wstd, but I probably need to pull that like repo.
Yes. Yeah. You should pull it down.
Up to date, git remote.
No, that can't be.
Git pull upstream. Oh, I need to set the upstream. Let's see here. So let's pull. Yep, this one. I guess I could do this. Can add a remote later. Ha!
Woo!
Success. Okay, and then did you have a link for me for the playground?
It is just in your URL bar here. Add a playground -wstd, or if is this your fork? This is your fork.
Yeah.
Sorry. Yeah. Just under my repo.
Playground
-wstd.
And you just casually created a standard library for WASI.
Yeah. Right, I was joking on like Mastodon the other day that, or was it? I forget where, but it's like do you know to say, or did I tell you this? The saying, the purpose of a system is what it does.
Okay.
Are you familiar with that?
No. Indulge me.
Okay. So you can like look it up on Wikipedia, but it's like a common thing where it's like, you can ask like a system like, hey, what are you doing? Or like, hey, what are you trying to do? But like oftentimes like what's on the label of anything, what's on the outside or the portrayed purpose is different from what it actually does. So if you just look at a system and you look at what the outcomes are, they can be like, well, the purpose of this system is to produce these outcomes.
Okay.
And sort of it cuts through like a lot of stuff. And so if you were to observe me, like, what is the purpose of me? Apparently it is to produce standard libraries over and over and over again.
You're the standard library factory.
Yep, basically.
Okay. So here's this is a funny what is my purpose meme generator. Have you seen Rick and Morty?
Oh yeah. Not the recent stuff, but like
Well, I think
have
this
seen
is in
like
the first season.
Yeah.
So this is what I did for my ops team couple. I was the lead for this particular team. But we still kept getting paged for one particular thing, and I'll write this out. So, what is my purpose? To restart app pools. So do you know what an app pool is?
That's funny.
In IAS.
What's IAS?
So IAS is, I forget what it stands for, but it's basically like the Windows Server web server.
Yeah.
Like the old one. So we had a bunch of like .NET apps that ran through through IIS, and so each app has an app pool inside the web server, and this was like 80% of our pages. So I put this together and put it in our team chat. Like, what is your purpose? To restart app pools. The original is like, what is your purpose? And he built him to slice butter and put it on his pancakes.
Oh yeah.
So producing standard library seems like a higher purpose than restarting app pools, but we automated it. We got through it. We got through it. All right. Another side quest complete. Here we go.
Yes.
Get clone, pull down the playground.
Yay.
Code RA dot. Getting good.
Ooh, love that.
Oh, and I should probably do the same. Oh, what am I doing? I'm in Tmux now. Haha.
Great.
Okay, so playground. Where do we begin here? We should save.
You go to the playground, try the /run command just for fun.
Let me
see if it builds
to my text file so we can put that somewhere. All right. You wanted me to go to the playground and change to where?
Oh, run the /run command locally.
/run.
Yeah.
See if our request works.
Yeah, because I did like a local link on the directory. I think it should work for you, but there.
Failed to read file. So do I need to open up that run and change something here?
Did it not build it?
LS target.
Yeah, let's take a look.
Debug.
Oh, you might need to. Okay. Try and update your Rust version.
Okay.
And then your cargo component version.
Okay. For Rust, is there a cargo command for that?
There's a rust up command for that.
Rust up. Do I have that? Is there an update?
Yeah, just rust up update should do it.
Nice.
You're plugged in, right? Internet?
Yeah, Ethernet.
Yeah, good.
Yeah, no more Wi-Fi for me.
Yeah. I was gonna say, like, if you're doing this on Wi-Fi, it might get a little spicy. This tends to take a sec. I think in a parallel tab you can I guess it's done. You can run a cargo install cargo component. This will also take a minute. Actually, I might run to the restroom real quick while this is downloading. Yeah, be right back.
Got some nice break music going.
Oh, lovely.
Yeah.
I'm kind of proud of my judgment here, where it was like, yeah, this will take about like long enough to like grab some water, go use the restroom. And then we
I
go
think that's
back
just a
into
testament to your familiarity with running the command.
Yep.
I will say it's good to be back on my Ubuntu instance. I put a lot of effort into getting to run smooth,
Nice.
but there's too many things on Windows that I use too, so I'll have to figure out a different solution.
Yep. Hey, and we're done.
Yay, we're back. All right. So
Woo.
you want me to just try to run the .run again?
Yeah.
Okay.
I think it should work. I'll like update. We changed the target name in the compiler from WASM30 to WASI to instead be WASM32 -WASI P1.
Okay.
And
Missing model line column 65.
interesting.
What file will that be in?
I don't know. Let's find out. Missing field model. That should be the main file. Try that
Main.
in the playground.
This one?
Yep.
Okay. What are we looking for? Well, line 1, right? Unused. Borrowing
Actually, does this run locally for me? Now I'm wondering. Like, it should not give that error. Running. Oh yeah, if you that worked. What? Missing field model. Line 1, column 65. That's the runtime error. It might be like a SERDI error.
Okay.
Yeah, if instead of okay, line 15, change the question mark into dot on wrap. Oh, you've got the relative lines on. Whatever the line with infer is.
Infer.
18, maybe?
Okay, there we go.
Yeah. The end of the thing, change question mark to dot on wrap instead.
Dot unwrap.
Yep.
Okay.
And that should panic and will give us a backtrace. Or maybe you need to do rust underscore backtrace equals 1 or something, but let's see. Yeah, okay, good. Okay, so that panicked. If we scroll up.
Okay. Panic. Environment variable display backtrace.
Okay, so it does indeed like panic here, but then it doesn't say like, oh, stuff came from somewhere else, which makes sense, I guess.
Failed to invoke run function.
Yeah, that would be the entry point. Okay, so I think it's just like a SERDI thing.
Should we print some of that out? Will that help? Or
okay, I think you can change it back to just be question mark.
Okay.
And then let's see what the string output here is. So I think if you scroll down a bit, not this function, not the next one, but the infer function maybe.
Okay.
Oh, the next one actually, Olama function. Then print the value of body.
Body right after this, like right here.
Yeah, before let body. No, before
Okay,
that.
right here. Okay.
Yeah, I think so.
And
So
is that like
DBG
debug?
bang.
Okay, like that.
Yeah, and then reference the body. Good. Yes,
Okay.
semi. I think.
Is that right?
I don't know if you did or did not write a semicolon.
Yeah, there is right there.
Okay. Yeah. Good. Then that's fine. Okay, try that.
Okay. Message 1 + 1, string false, missing field
Fascinating.
model. Oh, model's not being passed into here. Well, it's right there. Model.
Story JSON to string.
See that?
Oh, it might be on the response end. So try
Is that response?
further down.
Okay.
Down. Let output. Debug the output.
Okay.
The output
right here?
No, before. DBG, sorry. Yeah.
There you go. Output?
Uh-huh. Okay. Yes. Okay. Now let's see what the model, whether is a field model in here.
No.
That's just raw bytes.
Yeah.
Let's try and convert this to string. All right. The magic incantation to convert this to a string is so we're gonna rather than dbg just output, we can do uppercase string, uppercase s string. Oh, sorry. The string type is capital S lowercase string.
Okay, like this.
Yeah. Colon from UTF-8. Yeah, perfect. Great. Thank you, autocomplete. That's the one. Great. This is helpful. And now stick that inside of a DBG.
Okay, this whole thing?
Yeah. So a trick you can do is after the closing the closing thingy of unwrap, here autocomplete it. Or no, sorry. Type in .dbg and then hit autocomplete.
Or afterwards, like that?
No, before the semi.
Okay, dbg.
.dbg.
Like that?
No, the exact sequence is so. I'm trying to like teach you like a
shortcut. Okay.
Yeah.
I'm paying attention. Sure, ready? Go.
Okay, so you miss it. Yeah. Okay, so insert mode.
Okay.
.dbg. Tab. I think.
Oh, select that one.
No, tab. Yeah. Okay, great. Yeah. There you go.
Okay.
It's really useful if you so dbg works .sum to wrap it in sum, .ok to wrap it in okay. There's a couple like those. Okay. Did we? Oh, hey, that's useful. So model llama 3.18b not found. Try pulling it first.
Oh, because I don't have the model. Hey. Let's see here. Go to the Olama website. And what we were doing the Llama 3. Okay, so models. Pull this up. Some good air handling we could put in there for that.
Yeah, we should.
3.1. This is it, isn't it? Yeah. So I need to do that. I think we're getting better at this live stream. We're already at an hour.
Oh, wow.
It doesn't feel like it.
Doesn't feel like it. Time passes fast when you're having fun. Yeah. And other such cheesy lines.
Yeah. Close that.
Oh my god.
Going a lot
faster.
Have you
ever been, so not naming names, but have you like ever been in a company where we're one big family?
Yeah. The one that I well, at least my immediate team definitely felt like that. Yeah.
Oh, I mean, I want to call a distinction between like getting along with your coworkers and having like a good vibe versus the company like down saying like we are one big family.
Yeah, difference. Not. I've been at companies where they've said that, but it feels less like that. You
Okay.
know,
Yeah.
like when they state that. Yeah.
Yeah.
Is that what you're getting to?
Yeah. I'm not trying to like get you in trouble with like, please call out your former employers by name on stream right now. No.
I've been at where they claim to be a family, and it's
Okay.
definitely not family.
Yeah. I was like, what other like cheesy stuff can I say? And I was like,
Oh, we're
my
one big
mind just
family.
went there. I was like, oh my god, no. Okay, great.
Okay, so this
Great.
does this have to be running while you run this? It probably does, right?
Um, I mean, yes, it does. But I think the server might be running regardless. So I think you can just curl it
Oh, okay. So
because like
I could
when
close
when you
this right
curled
here.
it, it gave you a response already, right?
Right. Okay. Well, we'll just open a new terminal because it's nice and
Yes.
easy with Tmux. I actually really like using Tmux in VS Code.
Oh,
This
fun.
was happenstance because I
Uh-huh.
put Tmux to start on my Bash profile. So
Yeah.
then I just started VS Code. It started Bash and put me in Tmux. But now I
Mhm.
can. This is a lot easier than trying to like mess with this
Oh yeah.
window here and like Alt Shift caps lock pound sign to switch your tabs. I don't know, ridiculous shortcuts. Anyway, back to here. No, I didn't want to do that. I want to be down here. Okay, so now I should be able to get a model.
Yes.
Well,
Slash run, right?
Yep.
Oh yeah, two. There we go.
Okay.
That was two. Great. Now I think we can delete the debugs.
Let's document this.
Yeah.
Debug playground model not found error, something like that. That'll be a good anchor.
Yeah.
Ha. Try again.
Okay, and this will give us the. Okay.
Two.
Do you still have the error that you found?
The original?
Yep.
No.
It
might be in.
oh no. Oh no, it was below that. I saw the bytes, and we had to parse the bytes to like make sense of it.
Here we go. This.
No, not that one. The response from the server.
Oh, where it didn't have the error.
Yeah, there it is. There it is.
Right here.
That's the one.
Okay. Haha. Okay.
Yeah, great. Because we can take that JSON, stick it inside of like CodeGen thing, and then I'll be like, hey, actually the response is either this or that.
Okay. All right, now I've got it running. What's next?
Mm-hmm.
And if I think we're at an hour, so you let me know when you're good, and we can kind of pause whenever.
I've still got. I don't have anything right this second, and I think I'm still good. So if you are,
let me check.
Happy to keep going.
I shall check.
Yes.
Calendar. Nope, I am good.
Yay.
Continue. All right, so now we want to take all of this and make it a component.
Yes.
Okay. Or try.
Yes.
Or do I try?
Or let's hope the stakes are not that high.
Yeah.
Or just no. Try.
Give it a good college try.
Yes. Okay. So let's not commit copyright infringement, but let's use the power of open source to copy over schema from an open source project. It's not copyright infringement. Okay. I cannot stress this enough. We are not going to commit copyright. Okay. So if we go to the Spin SDK, they have the WIT files there.
Okay. Spin SDK.
Yep. Fermion for good measure, or Oh, it's the actual SDK. It's not Spin, but Spin
Okay.
dash SDK, I think.
Let's
Or
just go
maybe
to
check
their.
their GitHub. Yeah,
Yeah,
exactly.
let's just do this. Okay, SDK.
Mhm.
Rust SDK.
Yeah, the Rust one.
Okay.
There we go. And then in the WIT directory, there should be one. And then look for LLM.
LLM. Okay.
Yep. Font is a little small, but that's
We
okay. We just need
want
to copy it.
this
Yeah.
raw
Yes.
copy.
Let's copy that over.
Okay.
And
So
now we have a directory. Yeah. Inside of world.wit.
okay.
Just paste this.
Oh, you just had a boilerplate here. Okay.
Oh, yeah. And you don't have the WIT extension.
I do not. I can get it though.
Mhm.
Wit.
WITs by Bytecode Alliance.
This one.
That's the one.
So we talked about Norwegian cats briefly. I don't know if that was on stream or on stream.
Mm-mm.
Might have been on upstream. But when I don't know if this is a Norwegian expression or not, but twit was always that was one of the name of the cats because they were
Twit.
crazy.
Interesting.
Yeah, that would have been my grandmother. She was English. But that cat would climb the curtains, and like sleep up in their little like I don't know. It's like a metal border above the curtains.
Cute.
She was crazy.
That's funny.
All right. So this is what allows going back to the article, the WIT definition is the IDL, which is interface description language.
Correct.
And that is going to allow us to define the types, functions, and methods in the namespace.
Correct.
Okay. So we have this LLM interface. So where is the namespace defined in here? Well, that's what WASI namespace package.
So there's no namespace here. This may very well just fail.
Okay.
Because we just copied over like a random file from a directory. Now, if we try and run /run on this, we'll likely get a WIT bindgen error, but we can go from there. Because
we got two dot.
Can you check what's in bindings.rs generated on the left-hand side?
Bindings.
Yeah, nothing. Okay, good. Okay. So, or when I say nothing, I mean like this is the standard boilerplate that essentially does nothing.
Do not edit.
Yeah. Well, it says generated by WIT bindgen version so and so.
So, what's the relationship between the world and the bindgens? Is there a relationship? Like this should generate this, or this,
so
this should be based off of the world.wit?
Cargo component assumes a layout inside of your cargo assumes a layout inside of your like directory structure. Like, hey, your main file goes here, etc. Cargo component also assumes one, and it extends it and says, hey, if you have like any shared interfaces, I expect them to be inside of a directory called WIT.
Okay.
And it'll look there, and then it'll be like, okay, great, we have WIT definitions here. Let's create bindings to these, and then it'll like create the bindings to that. But in order to do that, it must like understand what's inside of it, and it will check for imports and exports. And right now, we're not importing or exporting anything, so it doesn't know what to do with it.
Okay.
And so we'll want to define that. Inside of the WIT, because right now it's just like an abstract interface. It says, hey, here's an interface LLM. Here's a record, which is like a struct result. Here's a thing called error. And it's like, okay, great. Do we import them? Do we export them? And we say nothing about that. So it doesn't create any bindings to it. Because if you import it, it's like a different interface you must generate than if you're exporting it, which is like a Rust trait.
Okay. So this is the bindings to the language?
Yeah. These are language specific bindings. And then world.wit is language agnostic.
And the reason for the width is so the bindings per language are consistent.
Yeah, every language gets to define their own bindings and how they should be exported. And at some point, the hope is that width will be stable enough and like a full-on standard, it won't change anymore. Maybe additive changes, but not like anything backwards breaking. We're already like kind of there, but we don't have the full assurance and guarantees of standard yet. It's still in progress. But once we hit that, you could imagine languages natively being able to target it from the compiler directly. Where you say in your struct, you might like say, hey, actually, the representation of this is like this width thing. Or as we export it, then natively it knows how to like convert it. Or,
Okay.
we can go for that deeper integration. But right now, not a full-on standard yet. It's just a draft. And so we generate bindings using an external tool.
Gotcha. Okay. Performing inferencing for large language models. Okay.
Yep.
So what do we need to do some import exports here? Because we're going to use it in a particular way. Or are we going to be?
Yeah, we're going to want to export this because we're building a component here, we're going to want to export it. And then we're probably going to want to create a secondary thing where we import it from.
Okay.
I forget what the syntax for that is. I think we can just reference hello WASI, WASI RS hello world, hello WASI HTTP bindings source. Wait. Depths world.wait. Okay. Okay, what we're going to want to do here is say at the top of our file, define this package. So we're going to say package space, and then your name or my name or anyone's name, it doesn't matter.
Okay.
Just so we have a namespace.
Okay.
And then colon, and then let's just call this LLM. And then semicolon at the end. And that becomes the top level namespace of this interface.
Okay.
And then underneath that, we're going to want to do a second one, which is world. And then let's call this LLM. And then open curlies. Yep. And then in a new line, we can say export probably LLM.
Like that?
Yes. Okay, try
So that exports the interface?
Yep.
Okay.
And now we can, is that correct? Interface LLM, type inferencing model, record. Oh yeah, all of it is defined inside of it. Yeah. And now we can try running it again.
Okay.
And this should create the bindings. Unless it doesn't, then we get to like debug it.
So we want to look at bindings.
Yes. Hey. Oh, no, this is not bindings.
That's main. Let's quit that.
Still nothing.
No dice.
Okay. Let's try WASM bindgen. What's the version of it that you have?
WASM bindgen, like that?
Dash bindgen, sorry.
Not found.
Ooh.
Did I spell it right?
Yeah, you did.
Okay. That's just a cargo, right?
Cargo install WASM dash bindgen. Yep. This will. Oh, dash CLI, sorry.
At the end of it?
At the end of it, yeah.
Like that?
Yep. Again, like all of these tools, they're like they're pretty good, but they're still in progress. So it's like not the smoothest user experience yet. Because I'm not sure why it's not. Oh, the directory wit is under source.
Oh, it needs to be higher up.
Yep, that might be the issue.
So playground.
Yep.
Okay.
Okay.
Did it?
It didn't move the. Where'd the world go?
Yeah. Oh,
What?
it just need a refresh.
Oh, okay.
It's there.
Great. Okay, try running it again.
Failed to parse local directory.
Duplicate item named LLM. Okay, so it's duplicate names. Great, we can fix that.
This name, package name, world name. What's the same?
Let's call the world.
Okay.
And let's try it again. Oh, world is a keyword.
W.
Sure.
There we go. Now
Great.
I want to look at the bytes. Ooh.
Yeah. Hey, there's stuff in there.
Okay.
So that's a lot of code. If you scroll the way down, you'll probably see, I don't know, 1,000 lines.
607, 606.
Okay, wasn't far off.
Okay.
And we can look at the docs for this, which is what is it? Oh, hold on. If you hop one back.
Hop one back.
Yeah. So go to main RS.
Okay.
Right now, we're not importing this. Say mod bindings.
Where at?
Line 2. Or I don't know which line it is. Yeah.
2?
No. Relative 2.
Oh, okay. So mod
Relative
here.
7. 10. Yes. Mod bindings.
Do you have to do that or to get rid of schema?
They're separate lines.
Oh, separate lines.
Yep.
No. What are we doing here?
Yeah.
Okay.
Okay. And now we can do in the terminal cargo doc. And then there's a flag for it. So run help. There's something about private items that you can like do. Include? No. Oh, document. Yeah, I saw it. Document something.
Document private items.
There we go. Yeah, see, hey, I was right about the private. Yeah. Oh, and then dash open, but that's fine. That's fine. Just let this run because we'll like instantly recompile.
Okay.
So try it again and do dash open after it. Yeah.
Oh, interesting.
Yeah. And now we can look at bindings somewhere, I think. Yeah. Exports. Modules. There you go. And now we have access to all of this. And the important one is traits, which is guest. Yeah. And so what we'll do is we'll implement, because we're exporting stuff, right? We have to implement the interface so that someone else can call this stuff. So when we compile it, we can link it in and people can call it.
Okay.
And so this will be the interface that we end up exporting.
Very good.
Mm-hmm. So rather than the main function, what we end up doing is saying struct something, world or something, or struct guest, and then impl that interface for thing. So we delete the main function.
Okay.
Oh, the entire main function? Yeah.
All of it. Okay.
Oh, yeah. No more main function.
No more main. Okay.
Yeah. Sorry, I'm kind of dictating here. Is that okay?
No, that's totally fine because
okay.
I have no idea.
Okay.
So it's good.
So maybe for rollback, so it doesn't feel like we're going one step at a time. So like understand the purpose. Right now we have a main function in a binary And what we're going for is we're going to convert this into a library that exports a type,
Okay.
or that exports a set of interfaces. And
And
so
we
what
don't
we
need-
do is we say we're going to define a struct, and we're going to implement this defined interface for that struct, and then we can compile that to what is a component, and it'll export the right things. It'll do the right like data marshaling, all that stuff. And then in a second like repo or a second like thing, crate, we can then define a new binary that imports this interface and calls into it.
Okay.
Does that
Yes.
track?
So yes. So this now becomes the component, and then we would have another playground too that would take it and actually use it.
Yeah, correct.
Okay.
Or
So we need,
we can do sub things, so we don't need to define a second playground. But for now, we're just going to export it.
okay.
So indeed, we define a new struct, and then we implement that trait for the struct, and then we go
Okay.
from there.
Walk me through that because I'm not too familiar with the Rust syntax.
Struct guest or struct component or something. Capital. Yeah. Let's say let's call our component.
So instead of guest component.
Yeah. Capital component. Yep.
And
then it contains nothing in it.
Okay.
Yeah, like that. And then we say impl. Not that. We're going to implement a trait.
Oh, trait. Okay.
Yeah. So we have our mod bindings. So it is bindings : double colon. And then I think it's LLM. Look what autocomplete says. Or I forget what the if you look in the docs.rs or the docs that we just pulled, you'll see the path for it.
I think I closed it. Let's do this again. Or I can split this.
Oh, lovely.
Maybe go this way. I've got the two monitors now, so it's not liking me.
Yeah.
All right, we'll do this.
Okay.
Come on. Make this smaller. Make that bigger. Hide. All that good stuff. Okay.
Okay. So in the left-hand side, if you like go through bindings, then
bindings, exports, Josh, LLM.
Yep. Then at the top, there's a little copy button.
Aha.
Yeah. And we can kind of paste that in, and we'll modify it a little bit.
Okay. Like this?
Yeah. And then rather than playground wstood, I think we can omit playground wstood, and we'll like check out.
Oh, too far.
And then the trait is guest. So : guest at the end. Yeah. And now you can autocomplete the impulse.
Guest. It's getting hung up on this. Add.
Impl 4, sorry. After this.
Okay.
So we implement a trait on something. So we say for component.
For component. Okay.
And that's not the right body. And now we can autocomplete it. The whatever the Rust analyzer gives you, the little sprinkles or stars or
okay.
The command dot.
Implement missing members.
Yeah.
Okay.
That's the one.
What is this?
And now you can save it, and it may compile. Let's see. You still have 4 errors.
Yep. Well, what's this one here? This RT, undeclared crate or module RT. Is that inaccurate?
Yeah, that's not going to be right. I think you can just say string.
Like that?
No. Just a bear.
Like that?
I think so.
Yep, that works. Okay. Generate. So just leave the string here.
Also, just vec and just string. Oh, you do need the. No, an angle bracket you were missing.
Angle bracket.
Yeah, just delete the RT prefix on both.
Okay. Oh, okay, gotcha. Leave that? Probably not.
Yeah, no. You're delete the double colon and replace it with an angle bracket between vec and string.
Okay. Like that?
Okay, so it's a vec containing string, and the way you
Okay.
say any generic param containing anything else is via angle brackets around it. So it's a capital vec.
Okay.
Do we have an example anywhere else? Yeah, like look on line relative 7. I don't know what line that
Okay.
is.
So
But you see option and then open brackets, like angle brackets. It's an
okay.
option of inferencing params. And
So
what is
like
that we have is
that.
correct. Are we
Okay.
missing one? Oh yeah, the outermost brackets need to go.
Okay.
Perfect. Yes.
Okay.
Okay. Sorry. I was trying to get us to that where it's like it's a backup string, and you were like,
What?
"What?" And I'm like, "Okay, hold on. Let me explain how generics work, maybe." Okay. And I think that should. Now we delete our main function.
Okay.
And then actually, let's simplify our interface for a little bit.
Okay.
Where we don't want to generate embeddings stuff. So for now, if we delete it from the WIT, it'll like also be removed from the yeah. Let's just delete it. It's fine.
Okay. But then I'll have to redo vec string.
No, I don't think so. I don't think so.
All right. What is this complaining about?
So now it's like, hey, you haven't implemented everything, and like that's okay. Don't worry about that. Let's
Okay.
edit our WIT file. And let's remove the generate embeddings function or comment it out here.
Right here.
Yeah.
Like that?
Yep.
Okay.
And now we can rerun this, rerun the main thing, which will regenerate the bindings. And now it won't include that function.
Okay. Main function.
Did it generate the bindings though? If you try and save it again? Oh, save it? Did you save it?
Yep. It's maybe I need to save the WIT.
No. I think it'll be right. Like it not having a main function is expected. It means we need to rename the file from main to libres.
Oh, okay.
Because we're building a library, not a binary. And save it again. Like the /run will no longer work because it's not a binary, yada yada. Oh, unless it does for some reason. What? What's happening? Oh, it's not compiling, but then it is running whatever the compile binary was.
Oh, the previous one.
Yeah. Cargo component check will do the same thing. Yeah, great. Perfect. Okay. And then the exercise will be to take what we have an example and I think. Oh no, we can delete example. Take what we previously had in our main file and make that what we export from exports.
Okay.
But I think I'm getting a little EP.
Yep, we're at 90 minutes, so probably that's a good linkage for the next stream, though.
I think so.
So take a main and export.
Because what we now have is the boilerplate to like actually follow through and create this, like fill in the blanks. One challenge that we'll have and we'll need to figure out how to overcome is making our interface async. Because if you look at the function signature of infer on line 19,
I'll turn off
the relative lines are like
next time.
Yeah. Like that does not have the async prefix, right?
Okay.
And so we what we want to do is we want to like provide an export that is either synchronous, and that needs to be okay. Or yeah, we can probably just make it synchronous for now, and as a later step, make it async.
Okay. Whew. There's a lot
Yeah.
of stuff. A lot of stuff. Good progress, I think.
Uh-huh.
I don't know how people do this for like 4 hours straight. That's impressive. I got a newfound appreciation for people that can stream for that one.
Oh yeah. Yeah. I mean, one thing that helps is like when it's just you and you don't have like someone else or like doing something you're comfortable with and not like doing new stuff. Because we're
Yeah.
like, yeah.
Yeah, this is all new stuff for me. So,
Oh yeah.
which is good. New language, new technology.
Mm-hmm.
So, I don't know. It's fun,
Definitely.
but taxing. Fun and taxing.
Yeah.
All right. Let's see here. Well, yeah. So, okay. So next time we'll take the main, we'll put it as the export, so then we can actually use the interface that we're combining, that we're building the component for. Okay, that'll cement it for me.
Next stream will be, I believe, next week Monday, right?
Next week Monday. Yeah, we've shortened the distance between them. Then we get a little bit more of a breather in between. But yes, next Monday.
Yes.
Next Monday.
For now, 2 streams a week still, Monday, Tuesday. That's our plan. And
Yes.
we might go to 3 in the future. But
might go to 3 in the future.
Yes.
I think we're picking up steam though. I think so too. Yeah. We're getting it going. All right. Well, we'll wrap that up for today. And then yeah, look out for the AKS community channel if you want to see the scheduled Monday session. Thanks for tuning in.
Thank you.
Everybody.
See you then.